All right, the next step with our felt board is we're going to add some cool things now. We're going to add some motion, and let me run an example here, and then we're going to add some interactivity to our program. So let's see if I can get this working. So here's the first applet. We're going to add a graphic. Then I'm going to click on the graphic to activate it, and notice that it moved. And then we'll be able to update that a little bit so we can sort of control its movement. This next one, when it hits the right side of the screen, you'll notice it bounces back. So we'll also be able to affect the speed. So those are a few things we're going to start with. You'll be coding the handout, moving graphic, then we'll be making some changes so that we have the effect shown in moving graphic part 2. So jumping back to the first motion graphic program, I'm going to just review a few things in here. The first thing you'll see is this integer pause time. One reason is the screen refresh can happen so quickly that if we don't pause, and this is probably going to be 20 milliseconds, it'll just execute so quickly that it's kind of, there's not much to see. So two other variables that we have velocity in the x and velocity in the y. Notice it's dx, dy, that's going to refer to delta or the change. We have an initial method. This happens before the run. This is when the applet initializes, and it's going to add our image first. So you can use an image that you used last class, or you can download something different. I just wouldn't make it too large. A new method we have, wait for click. You have to click on the applet in order for this to then execute. Otherwise it might happen so fast. This is a Boolean variable. Remember, Boolean variables, we didn't cover this much in Programming 1, but they're either true or false. So it's a yes or no situation. And the way it's going to work, it's like an old-fashioned cartoon. It's going to move over a little bit, pause, and refresh the screen, and then keep repeating. So it's just happening so quickly that it might look to you like fluid movement. Now this advanced one-step method is a call to this method that we've created down here, and that's going to change the x-coordinate. And then we're going to do object.method, and we're going to pass these parameters, the d value, and dx and dy. Now if you wanted to change its vertical movement, so it wasn't moving just left to right, obviously you might need something like this, dx plus plus. Remember, the plus plus means add 1 each time through. So if you wanted to change the movement of the, to make it go up and down, you would just have to change the dy value. Okay, now let's take a look at motion, moving graphic 2. And we have to figure out how is this going to work, and this is setting us up for Pong. How do we know when the ball or the graphic has reached the end of the screen? So if you scroll down here, we're in our advanced one-step method, everything in between here, and what we have to do is get the width of the applet, I believe, and then compare that to the position of our graphic. So I've commented out this line. That's what we had before. And now we have this. We have a new double called our logos X location. That's our horizontal location. If we wanted to do our vertical location, we could just change this to get Y. Then we're going to implement this method from the API. We're taking our logo, and the getX method will return its coordinate, and that's going to be returned as a single pixel. So that's going to come into effect later. Where we notice this is when I run the application. Notice when Saturn or whatever that graphic is comes here, it's not the right edge of the graphic that hits the edge of the applet. And I think it goes to the very middle. So our location, and let's take a look at this. Okay, there we go. It might be the left edge. We can specify that later, and that'll come into play. But the logo location right now looks like it might be the top left corner of the graphic. So keep that in mind. You notice, as I showed in that applet, the right-hand side of the graphic didn't bounce off. It was when the left side got to the edge of the screen that some action took place. And that action is two if statements. We have if the x location is greater than get width, which is the width of the applet. It's going to take our right movement, our movement along the x-axis in a positive direction, and make that negative. So now, instead of moving to the right, the negative version on a graph is to the left. You guys probably knew that. And if it's the opposite, it'll change it to positive. And then we'll move. Now, just to test that, or to make some changes, I'm going to change this to greater than or equals to see what happens. And hopefully this will have an impact on how my graphic bounces off the right wall. Maybe not. So let's try this. What we'll try is changing this a bit. So just to test it, we'll say the width of the applet minus 50. See if we can get that to bounce a little sooner. I'll compile. Yes, okay, so we gave ourselves a little gap there. Where that's going to come into play, say we're playing Pong, and this is my paddle here. Is it going to hit the front side of the paddle and then return the middle of the paddle? And when I say front, let's say left-hand side. Or is it going to hit the right side of the paddle and then bounce the other way? So we can kind of control where that exact bit, where that impact is going to be. And then see if you can get the ball to bounce off all four walls. So it's sort of bouncing up and down, left and right. It's just a self-contained little bouncing graphic. And that will be what we do for today.